Hey everyone, in this video, I want to show you guys how we can do linear regression on your ti-nspire calculator by entering a set of data points. The question I'm going to use as an example here is question number 8 from your topic 4 in class review package. The question says that students in science class conduct an experiment where they suspend different weights in grams from an elastic band and then measure in millimeters the length of the band for each weight. Below are the experiment's results. What we're going to do here is just graph the results here as x and y values, so as input values, and then it says to write down the equation of the regression line. So our goal is to get an equation for that regression line. On my ti-nspire, there's two ways of doing this, but I'm going to start by going to the list and spreadsheet option. Again, in home, this is list and spreadsheet. And we're just going to start by inputting your two columns. Now, you can name this anything. I could call this one mass and then length if you want to, or you can call it x and y. So we'll call this one mass. We'll call this one length. And we're just going to enter the data points. All right, so here I've got my data points entered just according to the example here in your handout. And what we'll do now is try to graph it. So how do we graph that? Two ways. I did show you guys briefly in class here how we get linear regression. So I'm going to go to a separate column now in our Excel sheet. You can click on Menu, go to Statistics, we'll go to Stat Calculations, and it gives us linear regression. Click on number 3 here. And for our list, now this time I didn't use X or Y, I used mass and length. You don't have to memorize that. You can click on it. So what I've just done here is press the right arrow, or you can click on where that is. So I press right arrow. My input is the mass. Based on the mass of that rubber band, we're trying to see how long it can stretch. Okay, so we put length here as our output. And you'll see here now it's given us a linear regression, title linear regression. Formula we're using is, or the form of equation we're using is mx plus b. Here is your slope, your m value. Here's b, your intercept here, your y-intercept. And then we also have r squared and r value. Just a quick review here. Your r value is the correlation. If it's a positive value, that means you have a positive correlation. For us here, we have 0.9, which is actually considered a strong positive correlation. And I can see that in my slope here as well, that it is a positive slope, but it's such a small number, right? How do I know it's a strong correlation between the two variables? Just because it's a positive slope for my line of best fit or my linear regression line doesn't mean it's correlated. But this tells me it's a very, very strong correlation. If you have a value that's 0.0 to 0.3, that's considered a weak correlation. 0 is no correlation. And then somewhere around 0.5, like 0.3 to 0.7, that's a moderate kind of correlation. Okay, awesome. So now we have our correlation, but what does that graph actually look like? We're going to add a new page here to our document. And to do that, I'm just going to go back home first. And instead of graphing using this one, you can graph using the pink button that kind of looks like a bar chart or histogram. And it just gives me these random values here. It says to click to add values. I'm going to go to my input, my x axis here, and click that. I want my input to be mass. Great, so I've added the mass. Now I'm going to my output, my vertical axis. I want my output to be length. There we go. And now I will go to Menu, Analyze, going to Regression, and I want that linear regression. I'm going to show the first one, mx plus b. And there you go, your linear regression line.